8th grade math students, Mr. Lawrence here, and we're continuing on with our learning, our education about functions, right? Recall that the definition of a function, wait, I can't get it, there it goes. A function is a relation such that each input, or x value, goes to no more than one output, okay? You need to know that definition. That will serve you very well in algebra next year and beyond. Okay, so a function is a relation. A relation is just a rule that assigns inputs to outputs. But functions are special. They're special relations where each input goes to no more than one output. All right, so I want you to determine if the following are functions. So there's three of them, A, B, and C. I want you to pause the video and be able to explain why or why not. Okay? All right, I'm hoping you've done those. Here are D, E, and F. Again, I want you to determine if they are functions or if they are only relations. Be able to explain why. And I want you to do the same for G and H. Okay? All right, I'm going to go back to A, B, and C, and I'm going to explain what the answers are and why they are or they are not functions. Please make sure you've tried all of them. Okay, so A is most definitely not a function. There are two really good reasons. The first really good reason is using the definition. The definition says that for a function, each input can go to no more than one output. I'm just curious, can you tell me the inputs of the function in part A? Well, let's see here. I could list them as a set. Let me see here. Okay, let's see. Looks like I might have a -4 there. That's one of my inputs. -2 is another. 0 is another. Ooh, that might be 3.5. I'm not quite sure. Oops. Didn't mean to close that brace there. All right. This 4, 5, 6. I don't know. 6 1/4. It's hard to tell. And then this would be 9. Okay. The inputs are just the x values. Check out the input of 0. The input of 0. It has two outputs. 0 goes to 3. But it also goes to -2. This is not a function. The first good reason why this is not a function is that it has an input going to more than one output. See how I use the definition directly? The second good reason, if you were paying attention last week, is that it will fail the vertical line test. Yes, a vertical line will intersect the graph twice. It fails the vertical line test. Okay, B is a function because no input goes to more than one output, or you could say it passes the vertical line test. Yeah. C is also a function. Again, no input goes to more than one output, and it passes the vertical line test. There is no horizontal line test. The vertical line test is actually a theorem, all right? Something that's been proven in mathematics. Excuse me. All right. D is a function because no input goes to more than one output. E is a function for the same reason. No input goes to more than one output. But wait, they're both going to... No. 2 is an input going to an output of 4. -2 is a different input going to the same output. That doesn't contradict the definition. Remember my analogy of people in restaurants. This is Taylor, and this is Paige, and they're both going to McDonald's. Not together. They just happen to run each other there, and they kind of do that awkward smile and wave kind of thing. Oh, hi, you know, because they didn't expect to see each other there. Okay, so this is a function. F is not a function because you have one input. You have Chloe trying to go to McDonald's, Burger King, Taco Bell, and Wendy's all at the same time. You have one input going to multiple outputs or more than one output. All right, G and H. G is not a function because you have an input 2 going to 8 and to 15. That disqualifies it. H is a function because no input is going to more than one output. 3 is only going to 4, 5 is only going to 4, 7 is only going to 4. 3 would have to be going somewhere else, or 5 somewhere else, or 7 somewhere else to disqualify it as a function. All right, one more problem I want to do with you, and then you are good to go for today. All right, it says when a scuba diver goes underwater, the weight of the water puts pressure on the diver. The table shows how the water pressure on the diver increases as the diver's depth increases. Okay, so what is the rate of change? In other words, they want us to find the slope. If it's linear, it might not be a linear relationship. So let's check it. Let's subtract this. Let's do that. Remember, slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's do that. So I'm going to have 8 and 8/10 minus 4 and 4/10. Sorry, I had some lag there. And then 20 minus 10. So that is going to give me 4 and 4/10 divided by 10. And divide by 10, I'll get this. Okay, that decimal pounds per square inch. Okay, there we go. Now, let's see if it is linear. If it's linear, that slope will hold steady throughout. So if it is, these are all going up by 10, right? Plus 10, plus 10, plus 10. If it's linear, these will all have to be going up by the same amount. And they're all, this first set is going up by 4 and 4/10. So let's do 8 and 8/10 plus 4 and 4/10. It's going to end in 2, carry the 1. It's going to be a 13. Ooh, I like that. It is. It is plus 4 and 4/10. And then if I add 4 and 4/10 here, I'm going to get 6. Yep, it is a linear situation. So the slope, since it's linear, the slope is going to equal 4 and 4/10 divided by 10, which of course is this. Okay, so now I could write an equation. Y is going to equal the slope. So y equals mx plus b, but b is 0, so I don't put it in. And they want me to do this part here, use the rate of change, the slope, to predict the water pressure on a diver at a depth of 60 feet, and then again at a depth of 100 feet. Okay, so it's like I'm continuing the input-output table. So I'm going to have 60 feet on here. I'm going to slide this work out of my way. There we go. So 60 feet, and then again at 100 feet. Okay, so the feet is my input. So the first thing I'll do is I'll do y equals this number times 60. Okay, and then I'll also have to do y equals this number times 100, which is the easier of the two problems. And I'll just do it like that, right? Because when I multiply by 100, the decimal point is going to move 2 places to the right. Okay, and over here, if I multiply by 10 first, I get this, and then I'm going to do that times 6 for carry the 2, 26 and 4/10, and there we go. There we go, ladies and gentlemen. That's part B. All right, that's the kind of stuff you're going to be doing for homework tonight. Mr. Lawrence signing off. Have a good day, everybody.